Hello. Next we are moving to the transformer. In this particular video we are going to discuss about the transformer working principle and the transformer impedance, as well as can transformer connected to DC supply, RF shielding. Up to that we are going to discuss in this particular video. So first of all we are moving to the transformer. So I will give the 3 points related to the transformer, then we are moving to the transformer remaining points. Okay, the first point here, very important. It transfer here, look at the two figures here. Transformer transfer the power from one circuit to another circuit without changing the frequency. Got my point? For example, you are given the 50 Hz is a frequency. What about your frequency here? You may expect 50 Hz frequency, then only it is a good transform. So transfer the electrical power, from one circuit to another circuit, but the condition here, without change in frequency. Without change in frequency. So one of the question, related to the SSC JEE examination. So the question here, transformer transfer power from one circuit to another circuit dash. They will give the options: power, first option; second option, energy; third option is a frequency; fourth option is a none of the above. So in this particular case, power is constant from one circuit to another circuit. If it is ideal, frequency is a constant. Only it can be changed the voltage level from primary to secondary, step up or step down, or current level, step up or step down, but it won't change the power, it won't change the what we call frequency. Okay, next one. So it is working on based on electromagnetic induction. So Faraday's laws of electron, working principle of transformer is Faraday's laws of electromagnetic induction. I explained already in the starting from these lecture videos. I explained what is a Faraday's first law, what is a Faraday's second law, everything I explained there. That's why I won't repeat it here. So Faraday's first law and second law. Faraday's first law state that whenever current flowing through a conductor placed in a magnetic field, in the first law, whenever current carrying conductor, it produces a magnetic field. Second law, whenever current carrying conductor placed in a magnetic field, EMF will be induced. But it is those are the Faraday's laws. Here Faraday's laws of electromagnetic induction, but it is not rotating conductor. The field is rotating here. So okay, let it be. We are discussing the topic after 5 minutes later, once we completed the construction part. Okay, still now everyone is clear about these 2 points. So then we are moving to we have two different type of transformer based on the construction. So the first transformer is a shell type transformer. The first transformer is a shell type transformer. Second one is a core type transformer. We'll see one by one. Core type transformer. So based on the construction, based on the number of windings, it is classified into normal transformer, that is a 2-winding transformer, as well as auto transformer. Okay, these are the two types. This is the actual 2-winding transformer, this is the auto transformer. This particular auto transformer I am going to discuss in the last part of the video. Then this particular video we are going to focus only 2-winding transformer. Okay, now this 2-winding transformer electrically connected? No, 2-winding transformer magnetically connected. So there is no electrical connection in between, both are isolated. That's why it is called as also isolated transformer. Okay, now we have we are moving to the two type of transformer, shell type and core type transformer. This transformer, this particular transformer figure related to the core type transformer. Core type. So core type means that primary winding placed in the one limb and secondary winding placed in the another limb. The total entire core is laminated here. This type of structure is represented in the figure. It is a primary winding N1 and then secondary winding N2. Okay. Similarly, similarly we have a primary winding N1, secondary winding N2. Now coming to the shell type transformer, the center limb placed both primary and secondary windings. This is also laminated. This is a representation of shell type transformer. This is a representation of core type transformer. Okay, everyone is clear about the shell type and core type transformer. Now shell type, both the shell type and core type transformer are laminated. Okay, only the construction point of view, this is a different winding placed is different. Remaining things, everything is same. Now in this particular case, based on the frequency, further based on the frequency, we are going to divide into. So next base. So here based on the frequency, we are classified into three types of transformer here: audio frequency transformer, and radio frequency transformer, and then power transformer. These three type of transformer we are going to discuss. Okay, now audio frequency transformers. Look at here in your some tape recorders, olden days, we will see this type of transformers. While you are open the particular radios or olden days, in that particular radios and something, this type of transformers is present. So what exactly the audio frequencies are transformer? What is the points you need to remember in the examination point of view? So this transformer operated on the audio frequencies. Okay, audio frequencies. The range of audio frequency, 20 hertz to 20 kilohertz. In between this is the audio frequency range. In this particular frequency range, it is going to be operated, as well as it is also laminated. So to reduce the eddy current losses, so it is also laminated. CL. Audio frequency transformer also laminated. What is the applications of this particular audio frequency transformer? They are primarily used for impedance matching. So I will tell you what exactly the impedance matching in the next last part of the video, because we have a separate topic related to the impedance matching. Okay, then another application here, amplification purpose. So that is a voltage amplification. So what exactly the voltage amplification here? For example, you are giving the 20 volt, you want to step up to 220 volt, for example. So the voltage increases whenever it is a primary less number of terms, secondary more number of terms. Thus, that is a voltage amplification is possible with help of this audio frequency transformer. So these are the some of the applications related to the this particular audio frequency transformer. In the examination point of view, they will ask the question like, for impedance matching, which type of transformer we are using? There is a audio frequency. Of course, remaining transformers are also used in the particular frequency range. This is the impedance matching device for the 20 Hz to 20 kilohertz transformer. Okay, the next one, radio frequencies transformer. Next we are moving to the radio frequency. So above the audio frequency range, this type of transformers are used. That is a radio frequency case. Above audio frequency range, we are using RF transformer. Okay, so in this case, this particular transformer manufactured with ferrite core, because it is a very high frequency, right? We need to reduce the eddy current losses. Ferrite core is mostly adjustable core is using. RF transformer have the either both the windings are tuned. That means conjunction with capacitor. In case of RF transformer, so both the windings are conjunction with capacitor. Conjunction with junction capacitor. Why? Because it is resonant with the circuit which works on the particular frequency. So here frequency range is high. If we want to tune the frequency, So we have to connect it both the primary and secondary winding to the junction capacitance. We can tune this capacitance, we can tune the frequency. Okay, so this is related to the radio frequency transformer. At the last, power transformer. So in our electrical engineering, maybe you are electrical or electronics engineering, some transformers in the power stations, you may observe some big transformers like transformer oil breather, everything is present. Those transformers are the power transformer, which can transfer the power from one circuit to another circuit without changing the frequency. It having two windings, primary and secondary winding. These are the transformer tanks. And then this is a transformer, what we call outside core, mm, protecting core. This is a different structures of the particular transformer representation. So what exactly the power transformer is doing, already mentioned, it transfer the power from one circuit to another circuit, as well as it provide the step up or step down the voltages, step up as well as step down voltages. We can use this type of transformer. So this type of transformers are used in power systems and industries also. Okay, this type of transformers, uh, this power transformer, without power transformer we can't uh, transmit the power from long distances, because for example, we have some substation is there. I will tell you, 230 by 440 volt. This is a domestic purpose voltages ratings. So this voltage can be 11 kV is available nearby substation. We can use this 11 kV directly in your home applications. No, this 11 kV connected to the distribution transformers. The distribution transformer to step down to 230, or in case of 3 phase 440, and then given to the our home appliances, domestic purposes. So that's why it is a major role in electrical engineering, transformer, one of the main component. Now we are one of the interesting one, transformer working principle. Still now we got the everything about the transformer, then we are moving to the transformer working principle. Okay, let us see the transformer working principle. So here transformer is connected to primary to AC supply. Okay, I connected primary to AC supply. Whenever primary connected to AC supply, the current will be flowing through the conductor. Whenever current will be flowing through the conductor, according to induced EMF is generated in the primary conductor, dN into d5 by dt. Okay, this induced EMF, this particular induced EMF is responsible to flow the current through the primary winding. Now this particular magnetic flux, due to the effect of this current, particular magnetic flux are carrying, the particular magnetic flux are flowing through, passing through this magnetic material, this magnetic core. Okay, your core is provided to less reluctance path. Reluctance means it less opposition to the magnetic flux. Then in the first case, everyone carefully listen, magnetic flux are flowing from the primary to secondary. So whenever magnetic flux are passing through the primary to secondary also have a winding. Due to the mutual induction, okay, this magnetic flux are cutting to the secondary winding. Whenever magnetic flux are cutting to the secondary winding also induces the induced EMF. Okay, for example, this is the E1, this is the N1. Secondary case also induces the induced EMF d5 by dt N2 into. Okay, whenever this induced EMF induced in the secondary winding also connected to the load. Whenever secondary winding connected to the load, this this particular induced EMF is supply the electrical current to the particular load. Got my point? That means we are given the current, we are also supplying the current without any electrical direct connection. This particular entire link is a magnetically coupled. So these are the magnetically coupled. So only transfer the energy from one circuit to another circuit magnetically. There is no electrical connection. That's why it is a isolation transformer, you can call it as a. Okay, clear. Up to this it is clear. So after induced EMF, due to the load, some extra current will be, whenever connected the load, some extra current, that is a I1 prime, due to the effect of load. According to conservation of energy neither be created nor destroyed. Whenever it is take the load, more and more load, what will happen? More current will be drawn here. That current will be taken from the primary itself, right? That current will be I1 prime. Maybe extra current will be taken from the supply whenever load is connected. This primary current again to generate the some magnetic flux, right? So before that, see here, this current will be generated, right? In the secondary winding, that current will be again cutting to the same magnetic flux, right? These magnetic flux are flowing this direction. That flux, for example, this is a phi 1, this is a phi 2. Again this magnetic flux are cutting here. Due to that, some extra current you are taking, right? I1 prime is generated. Okay, that I1 prime again to responsible to generate the magnetic flux here. In the third case, that magnetic flux is this direction. So that magnetic flux we can consider as a pi. So how many magnetic flux are present? Initially, the magnetic flux is phi 1, is a one direction. After that, due to the load current, second current will be generated. Due to the effect of load current, the secondary current, the primary also some compensation magnetic flux are generated, which is the direction forward direction. That is a flux phi. Okay, so finally, two magnetic flux are passing opposite to each other. What will happen? Both the flux are cancel with each other. Whenever both the flux are cancel with each other, what will happen? The flux phi is only present. That means finally my conclusion, why I'm explaining all these things, because you are going to proper working principle of transformer. You can attempt the question in the examination. They will ask you, magnetic flux is constant. Magnetic flux is constant from primary to secondary. Whether you can consider primary or secondary winding, the magnetic flux is constant, because these two magnetic flux are cancelled with each other. The magnetic flux phi is a constant. The constant means that there is no phi 1, there is no phi 2. Only one magnetic flux is present throughout the primary as well as secondary. Okay, that point you need to remember. Irrespective of the load you are connected, the magnetic flux is constant from primary to secondary, from no load to full load, from no load to, very very important, no load to full load. Got my point? In no load, without connecting the resistance, only one flux is present. After connecting the resistance also, after closing the secondary side also, the flux is same. That is a no load flux, is a full load flux. Both the cases the flux is constant. Okay, clear? Now how to decide it whether it is a whether it is a transformer is a higher step up transformer, step down transformer. We have two cases. For example, here a number of turns N1 and N2. For example, I design the transformer more number of turns in the primary. What will happen according to these two equation? Here more number of turns, what will happen? More induced EMF is generated. Here for example, here less number of turns, what will happen? Less induced EMF is generated. So from that, the number of turns is, for example, Nt is more than N1, then what will happen? V1, V2 is more than N2. Okay, V2 is more than, V2 is more than V1. So this is a step up transformer. What it means? Step up transformer. The step down transformer case, N1 is greater than N2, V1 is greater than V2. It is a step down transformer. Okay, step down transformer. Clear? So it is a step up and step down. One more important point, transformation ratio K. Very very important. Transformation ratio K is equal to V2 by V1 is equal to N2 by N1. Okay, how the transformation ratio you got it? I will give the small derivation. It is not required for you in the examination, but if you know the concept, then you can remember the formula. It is easy way to understand. So power is constant. According to the definition, the transformer transfer the power from one circuit to another circuit without changing the frequency. In an ideal case, power P1 is equal to power P2. Okay. Power factor, for example, power factor is constant. Okay. So power P1 is equal to power P2. P1 formula V1 I1, P2 formula V2 I2. From that, V1 by V2 by V1 is equal to I1 by I2. You got the relation now. So according to this relation, already you know K is equal to V2 by V1, that is equal to N2 by N1. That may be equivalent to V2 by V1 is equivalent to I1 by I2. According to this relation, that will be equivalent to N2 by N1. This is a one of the important formula you need to remember. Okay. So one more important thing I would like to mention here. After transformation ratio, turns ratio is a constant. For example, turns ratio is nothing but a volt per turns ratio is a constant. Volt per turns ratio is nothing but a. For example, I will consider these two equations. V2 by V1 is equal to N2 by N1. From that, V2 by N2 is equal to, so V2 by V1 is equal to I1 by I2, that will be equivalent to N2 by N1. Already we wrote. Okay, so I will tell you one more important formula for you, that will be turns volt per turns ratio. So here V2 by V1 is equal to N2 by N1. From that, V1 by N1 is equal to V2 by N2. So that means turns ratio is constant in the transformer. So irrespective of the voltage in the primary or secondary, we are consider the turns ratio is always constant. Okay, that point you need to remember. Finally, what are the important points related to the transformer? I explained everything for you. So you are preparing for the examination. This small part is mentioned in the 7th chapter. One of the topic is a transformer. So don't go too much. What I explained here, that is enough for the transformer case. Next we are moving to the transformer impedances. Okay, so still know, you know, transformer having primary as well as secondary, transformer having a primary current, secondary current. Similarly, transformer also having a primary impedance and secondary impedance also. So in this particular circuit, what exactly I am going to explain to you. For example, this particular Z1 referred to secondary side, what is the formula? This particular Z2 referred to primary side, what is the formula? Because this is a magnetic circuit. With magnetic circuit, you can't analyze the circuit in the practical cases. This magnetic circuit can be eliminated and convert into electrical circuit, then you can analyze it, anything related to the transformer. That's why I will give some formulas to you. Those formulas may be in the examination purpose, it is important for you. In the 2015 question paper, 16 question paper, they provide one question from this transformer concept. Okay, we'll see how to write the impedance. You know, Z1 is equal to square root of R1 square plus X1 square. Okay, so similarly Z2 impedance is equal to square root of R2 square plus X2 square. Okay, now my question to explain to you, if transformer, for example, Z2, this particular Z2 viewed, that means seen from here, this particular Z2 viewed from here, that means this particular Z2 referred to primary side, transferred to primary side, the formula is equal to Z2 dash is equal to Z2 by K square. Got my point? So if you want to transfer the impedance from secondary side to primary side, the formula here Z2 by K square. Next, if I want to transfer the current, for example, I want to transfer the current, this secondary current to primary, I2 prime is equal to K times of I1. Okay, if I want to transfer this voltage to primary side, V2 dash is equal to V1 by K. I2, V2, sorry. And K into I2, here V2 by K. Okay, these are the formulas you need to remember. This is referred to refer to primary. Okay. Next I will give the another formulas to you. Refer to secondary side. Refer to secondary side. In case of refer to secondary side, the formula Z1 prime, that means you can see in from here, this particular Z1 convert into here, Z1 prime, Z1 dash is equal to Z1 divided by K square, sorry, Z1 into K square. Got my point? It is a reverse of that. Now coming to the current, I1 dash is equal to, this current is referred to primary side is equal to I1 by K, opposite to that. Next, V1 prime is equal to V1 into K. Okay, these are the formulas is enough in this particular case, transformer impedances formulas. So in the examination they will ask you like that, the impedance of a particular transformer secondary side is at 10 ohms, that particular impedance is transferred to primary side, what is the value? So simply you can apply this particular formula, these particular formulas we can calculate the values. Okay, here K is nothing but a transformation ratio, just now explained. V1 transformation ratio V2 by V1 is equal to I1 by I2 is equal to N2 by N1. Okay, clearly you should remember, in case of current only I1 by I2, remaining voltage and turns ratios are both the same. Okay, one more formula I need to mention here. Here for example number of turns N1, here number of turns N2. Here number of turns N1 and number of turns N2 decided the step up or step down transformer. So those number of turns here both are electrically disconnected, magnetically coupled. Okay, these points are enough for this case, particular transformer explanation. Then in the next we are moving to the some problems related to the transformer, then we are going to the remaining topics. Okay. Okay. Next, second example. See here, a power transformer has 100 primary turns, right, and 600 secondary turns. So we have a transformer, power transformer. This is a transformer. Okay, this particular transformer, we have a number of turns in the primary is 100, number of turns in the secondary is 600, and the primary voltage here 120 volt, and full load current in the primary, that is at 12 amperes. Find secondary voltage, that means the voltage across here, secondary voltage, as well as the secondary current, that current will be I2. So you need to calculate both. So by using that V1 by V2 is equal to I1 by I2 by I1 is equal to N2 by N1 by N2. This is the relation So by using this relation, I am going to calculate the remaining parameters. First of all, I am going to compare K is equal to transformation ratio is equal to N2 by N1. So that will be equivalent to V2 by V1. That will be equivalent to I1 by I2. Very important. They are asking about this concept also. What is the transformation ratio? The ratio of secondary voltage to the primary voltage is nothing but a transformation ratio. So just simply directly you can calculate V2 you want. V2 divided by what is the V1 120 is equal to N2 already 600. What is N1? N1 is 100. So from that these two zeros get cancelled. Then you will get V2 is equal to 6 into 120. So 720 volt. So the first portion is done. What about the second part? The second part, current. The current value I1, you want I2. I2 by I1 already given 12 is equal to N1 here important. I2 by I1 is equal to N1 by N2. What is a N1? N1 is 100. N2 is 600. Here 20 get cancelled. I2 is equal to 12 by 6, that is equal to 2 amperes. So finally you got the values are 720 volt and 2 amperes. This is about the solution. So here a low voltage soldering rod taking 40 amperes. So the problem here, 40 amperes at 12 volt. So it is given. So that means the current I2 is equal to 40 amperes, because your transformer this is connected to some soldering rod, right, with voltage of 12 volt and current of 40 amperes. Some soldering rod is connected. So now what about V2? V2 is equal to 12 volt. Fine. It is operated from of secondary side. It is operated of a 240 volt transformer. That means what is a V1? 240 volt. Got my point? So calculate number of turns ratio. So turns ratio is nothing but a N. Turns ratio is nothing but a N2 by N1. That is a turns ratio. How much you need to find? You need to find out turns ratio. Second one, primary current, that means I1 value. Okay, these are the things you need to find. In the examination, they want to ask you any I1 value or turns ratio, any one bit. They will ask you both the bits. If they ask you both the bits respectively in the options, N2 by N1 is 1 by 20 comma 2 amperes. Other option 1 by 40 comma 5 amperes. Third option 1 by 60 comma 6 amperes, and D is none of the above. That type of options like that. Okay, so do the problem now. So here turns ratio, transformation ratio, K is equal to V2 by V1, that is equal to 240 divided by 12, that will be equivalent to 1 by 20. Therefore turns ratio, this formula, K is equal to V2 by V1 is equal to N2 by N1. That means the K value can replace here. N2 by N1 is equal to K, that will be equivalent to 1 by 20. This is the first bit answer. Coming to the second, what is the formula? K is equal to V2 by V1 is equal to I1 by I2. K value is 1 by 20. I1 value, you don't know I1 value. I2 value is 20 is equal. I2 value is 40 in the given data. Sorry, I2 value is 40 is equal to K value is 1 by 20. If you replaced it, I1 is equal to 40 by 20, that will be 2 amperes. Okay, this is the answers. 1 by 20 comma 2 amperes. So if you just thoroughly with these formulas and then transformation ratio concept, already in the theory it is explained. So you remember those formulas. In the examination, this type of questions will be asking in the previous examinations. Trend is going on. Maybe you are expected some of the questions like that. So this is a problem number 3. Can a transformer operated on DC? That is a question. It is also one of the previous paper question. So listen carefully everyone, whether if transformer connected DC supply, what will happen. So let me take transformer. Okay, in this particular transformer, primary having winding, secondary having a winding. Okay, if I connect DC supply here, transformer, then what will happen? See, induced EMF formula in the primary side, E is equal to number of turns into d phi by dt. right? So that means whenever the current will be flowing through this particular winding generate the magnetic flux, no problem. So it induces the magnetic flux, that is a phi. That magnetic, if you are connected DC supply is a constant DC supply, what I mentioned here, constant steady state DC supply. Whenever constant DC supply you are connected to this particular winding, then what will happen here, the magnetic flux, the magnetic flux is also constant magnetic flux is induced. Okay, whenever the constant magnetic flux is induced, so whenever derivative of constant here, constant magnetic flux derivative of constant is equal to 0, that means the induced EMF in this particular case it is 0. Whenever the induced EMF is at 0, that means that total entire voltage is equal to 0. So voltage is equal to 0 means this particular winding current will be maximum, that means short circuit current will be flowing. Whenever short circuit current will be flowing, the power losses P is equal to heat losses I square R. Whenever this is a short circuit current, very high current, that means square times of heat will be generated, very high current. That means short circuit current 7 times of full load current. No, that means 7 times of square of the current will be induced. That means the power heat losses, so much of heat will be generated in the transformer. Whenever so much of heat will be generated, what will happen, winding going to be burned, transformer winding going to be burned. So what happened if transformer connected DC supply, this is the thing happened. That's why if transformer connected DC supply in the examination, they will ask you, you can choose the option transformer going to be burned, it cannot be produced as any electrical power supply from one circuit to another circuit. Look at here. So if you are connected this type of supply to the transformer, okay, it is connected, no problem. It transfer the power from one circuit to another circuit because it is alternating. So you may get the doubt, the alternating may be positive or negative, then only it is working. Another thing, it is not working, another waveforms, you may get doubt. Now that doubt I will clear here. This is also alternating waveform, but there is no positive, there is no negative cycle. This is a pulsating DC. In this particular pulsating DC, variable is present, right? So variable change is present, that's why it is also working. Pulsating DC also it is working. So that's what I am going to explain here. So transformer will operate from the DC voltage also. This particular case DC voltage also undergoes some changes of transformer, that is a audio amplifier working on pulsating DC. Small changes here in the transformer. The transformer we are call it as an audio amplifier. In case of audio amplifier transformer, we can use this type of pulsating DC. Small changes in the power transformer. So this is about the power transformer operates on DC. Okay. RF shielding. At the last topic in this video, magnetic shielding and RF shielding both are different. For example, in the transformer, we are providing the RF shielding. Some case here, RF shielding. In that case, what exactly it is doing, just 1 minute, I will conclude that. What exactly it is doing, you want to protect from the external magnetic flux, right, or earth magnetic field. So we are using this RF shielding. But in case of internally we have a magnetic flux, that is a variable magnetic flux. That means it only protect from the constant magnetic flux. That is a what mean constant magnetic flux outside. What are the magnetic flux outside? It is not useful in the useful for the transformer. That only it is opposes. Okay, remaining everything within the transformer working, it won't disturb. Okay, this type of shielding we are providing in this particular case, RF shielding. Okay, this is enough for this particular topic. So finally we conclude that we completed up to transformer. Then next we are going to discuss about the auto transformer. Next, impedance matching. With that we can complete our 7th unit. Thank you.